So I want to do a quick primer on Trig, since I recognize that not everybody will be familiar with Trig. So when you start with Trig, it's often best to start by considering right triangles. So I've got my generic right triangle, and I'm going to call this angle theta. Now I could have gone with the other angle. It doesn't particularly matter, but I had to name one of them. So the diagonal of a right triangle is often called the hypotenuse. It's the side length opposite the right angle. In other words, it's the longest side. Then when you've specified an angle, the side of the triangle next to that angle that isn't the hypotenuse, that's called the adjacent side. And then the remaining side, the one opposite the angle, is called the opposite side. We're mainly going to be focused with sine and cosine, but I'll also cover tangent and give y'all a little mnemonic for how to remember how these different trig functions are defined. The mnemonic is so, ka, toa. What this means is sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. But what does that mean? So I've written an e here on the sine, but when you actually write out the sine function, that e is not there. Let's evaluate sine of theta, cosine theta, and tangent theta on our triangle here. So according to our mnemonic, sine is opposite over hypotenuse. So I'll just write that out here. It's the length of the opposite side divided by the length of the hypotenuse. If I can spell hypotenuse, then cosine of the angle theta is the adjacent side length over the length of the hypotenuse. And then tangent of theta is the length of the opposite side over the adjacent side. And that's how these trig functions are typically defined on a right triangle. And so, if I were to put this in terms of letters instead, redraw my triangle here, angle theta, side lengths A, B, and C. You have sine of theta would be B over C. Cosine of theta is A over C. And then tangent of theta is B over A. And from these two, it's important to note that tangent of theta can be defined in a slightly different way. It's sine of theta over cosine of theta. So using the notation that with A's, B, and C's, we get B over C over A over C. And then if we multiply both our numerator and denominator by C, same as multiplying by 1, we get canceling of the compound fraction, and we just get B over C. So now I want to prove a specific identity that's going to come in useful later on. So I'm going to draw one more right triangle. This one's going to be a little special. So it's going to have lengths A and B, angle theta here, but the hypotenuse I'm going to make be a length of 1. And so what does that mean? Well, if we apply the Pythagorean theorem, we get a squared plus b squared equals 1. Okay, now let's look at the trig functions for this triangle, specifically sine and cosine. So sine theta, it's going to be opposite side, so b, over the hypotenuse 1, so sine theta is b. Similarly, cosine theta, it's going to be the adjacent side, or a, over the hypotenuse, which is 1, and so it's going to be a. So if we take those values and plug them in there, then we get sine squared of theta plus cosine squared of theta is equal to 1. And that's true in general. That's always going to be a true statement. And the reason that's going to become important, I'll actually bring up in the next video, because this is going to be a 2-part series on basic introduction to trig for what we need it for. The next one, I'm going to prove a couple of identities. Specifically, I'm going to prove that the sine of x plus y identity, the cosine of x plus y identity, and then I'm going to use those identities to find some other way to write sine of x in terms of cosine of 2x, and then cosine of x as a way in terms of cosine of 2x as well. And we'll find that that becomes very important when we look at the golden ratio. See you in the next video.